Okay.
Okay. Once again, thank you everyone for coming. Just a couple of little housekeeping things. You may see two instances of me on this session. That's just because I usually run my phone as a backup. You never know what happens with technology. Things go strange. So if anything does go red with the computer, I will switch over to the phone. Unfortunately, we may lose the presentation, but I will just continue talking through the session. So today's session is all about engineering and renewable energy. And so that is the focus of my talk. And I'm just trying to make sure I don't get any echo from my phone. And so what I will do first is I will talk a bit about the various renewable energy technologies that are popular and available to the utility industry, which is the entity that I represent as BPL, and it's a form of renewable that people always hear about the most in the market, primarily. So generally speaking, we all have an idea of what renewable energy is. An official definition says that renewable energy is any source of energy that is naturally regenerated over a short time scale and derived directly from the sun, in the case of thermal and photochemical and photoelectrical, indirectly from the sun, such as wind, hydropower, photosynthetic energy that is stored in biomass, or from other natural movements and mechanisms in the environment, such as geothermal and tidal energy. So that definition basically gives us a good overview of all the different types. Just to mention them once again: hydro, which I'll go into some more details of each of these. Wind, geothermal, solar PV and thermal solar, ocean thermal, ocean tidal and wave current, biomass energy, and cellulosic ethanol, biogas, and hydrogen fuel cells. All of these various technologies are used for producing electrical power, electrical energy. The most prolific, or one of the most prolific forms of renewable energy is hydropower. Hydropower is used in many countries around the world, and by its very nature, it generally is used for large capacity installation. There's significant capital costs in developing hydro installation, usually requires damming up a river, which in turn floods areas that all have to be evacuated. Often there's displacement of populations, these sort of things. But hydroelectricity, due to its nature, can generate very high capacities of energy if you have the suitable environmental conditions. So if we look at those, the Three Gorges Dam in China, which is one of the largest installations in the world, produces 20,300 megawatt hours, which is about almost 100 times, around about 100 times the demand for the island of New Providence on average. So it gives you, and that's just one dam facility. So this shows you what can be achieved with renewable energy in the hydro arena. Wind power in recent decades has gotten more and more popular. Wind power comes usually in two forms. It either can be on land or it can be offshore. Generally, it's offshore when land availability is a challenge or when the wind regime on land is not practical. Also, wind turbines tend to, in some people's mind, be a blight, and so they don't want them near them. And the reason for this is the size of a wind turbine installation is often underestimated by persons not familiar. So these pictures give you an idea of scale of a wind turbine installation. So this picture here, you'll notice on this wind turbine, the crew member is being brought to the turbine to do maintenance via helicopter. And you can see the scale of the helicopter in comparison to the wind turbines in the cell and its blades. And another indication of how large they are, this airplane represents a Boeing 747. So if you had a large commercial wind turbine, in this case, this was about a 5 megawatt unit. You'd see the wingspan or the blade span on a turbine is actually wider than the wingspan of a 747 jet. Another form of renewable energy that's available is geothermal energy, which basically uses the energy in the earth in order to heat working fluid, usually water, to produce steam, which then drives turbines. There's solar and PV and solar thermal energy as well, which comes from the sun, of course, and is used to generate either heat or electricity. Here in the Bahamas, solar energy is probably the most viable source of energy for us. We have no rivers in order to do hydro. We have no volcanic activity, and I'm kind of glad, in order to do geothermal. And the wind regime here in the Bahamas is not very strong. We get hurricanes, but they are for a very short-lived period. And generally speaking, outside of that, the quantity and the rate of wind speed you need to sustain a commercial-sized wind turbine is outside what we have here in the Bahamas. So solar is what we have been focusing on in general. And as you can see, there are different versions of solar. There's PV solar, which people are very familiar with these days. Thermal solar, which should be popular in the Bahamas for hot water heating, but we are not using it anywhere near as much as we should. Passive solar is a way to heat a building and also keep a building cool through the design of the building itself. There are thermal solar plants that on a utility scale use an array of mirrors to reflect sunlight to a central boiler or heat exchange unit that is then used to produce steam or some other working fluid to drive a turbine and produce electricity. And then there are the large-scale solar PV fields that have become more and more popular in recent years as the price of solar panels have been dropping significantly. Another technology that would be of great benefit to the Bahamas when it is fully commercialized would be ocean thermal energy. Currently, there aren't any commercial scale operations of ocean thermal anywhere around, and therefore most of them are still in development or research stages. But ocean thermal effectively is a heat cycle where warm water near the surface of the sea is used to evaporate a working fluid. That working fluid then drives a turbine. The exhaust from the turbine goes through another heat exchanger, and cool water from deep in the ocean is used to turn the working fluid back to a liquid form. And then that is pumped through the cycle again, and the cycle continues. Clearly, given the amount of ocean available to the Bahamas, this sort of technology, when commercially available, would be something that would be of interest to us as a nation. There's also tidal wave and current-based technologies. These also are still very much in the development phase. There are some installations done by researchers, etc., but there's no practical power station operational on a large scale anywhere yet. And one of the things we as a country are not in a position to really do is get out on the bleeding edge of the technology, because that is where the cost is high and the risk is high. And so we tend to want to work with the technology when it's more mature. As you would expect, anything that sits in the ocean, some of the biggest challenges from an engineering perspective are dealing with the actual environment, the corrosive saltwater environment, the active sea life and marine life that will tend to accumulate on equipment and machinery and therefore cause it not to function as it should or not to function efficiently. And so this is where a lot of the research is being done to address these issues.
Mr. Strachan, is this the engineering class?
Yes, it is.
Okay, thank you.
Biomass is another form of renewable technology that can be used to produce energy. Biomass essentially takes a carbon-based fuel source such as waste crops, sewage, municipal solid waste, animal waste, convert that to a fuel type, usually by drying it and pelletizing it in some fashion, and then combusting it to produce heat, which is then used to again drive steam turbines in most cases. Biogas, unlike biomass, does not actually combust the fuel as part of its production cycle. What it seeks to do is allow the biomaterial to break down and generate gases. These gases are then dried and treated because they tend to be a carbon-based, hydrocarbon-based gas, and that hydrocarbon-based gas can then be combusted in the same way other gases can to produce energy or to drive an engine directly once properly completed. And one of the new technologies that are out, not so much new, it's been around for quite a while, but it's now making more and more headroom, so getting closer and closer to commercial implementation, is that of hydrogen fuel cells. Hydrogen fuel cells, again, one of those technologies, when perfected, can be a game changer. Essentially, what you do is you take hydrogen and you put it through a fuel cell, which then, due to a chemical process within the cell, converts the hydrogen to water, heat, and electricity. Hydrogen fuel cells can be as high as 80% efficient, and you compare that to diesel engines and automotive engines, which run around about 28 to 30% efficient. You can see there's a significant advantage of going in this technology direction. Theoretically, there's an abundance of hydrogen on the planet because you could separate water into hydrogen and oxygen. And effectively, what this process then does is combine the hydrogen and the oxygen in the air and convert it back to water. And so it's a very good closed loop type of solution. So in thinking about renewables, we have to think about where we are now and where we are going. And so primary energy sources at present, and this is some information from around about 2019, 2020-ish, indicates that we're still heavily invested in fossil fuels, oil, coal, gas. The non-fossil fuels, or the low carbon energy sources, still make up a very small percentage, about 15%, 16% in this case, with about 12%, in total being about 11.5% being from renewables. Nuclear power is considered a clean or low carbon energy source, and some people consider it renewable, others don't. It's not truly renewable because essentially you still need to mine the materials to produce the fissionable product to feed the reactor. But it is clean compared to other technologies. What is good is that the world's direction with respect to renewable energy is changing. Governments around the world are realizing it is necessary to change what we are doing now if we're going to fight off things like climate change, if we're going to fight off the volatility in economies due to fluctuations in fuel prices. And so many countries have created policies that by 2040, if implemented and as indicated, will drive us towards about 50% of the energy being produced by renewable sources. With continued sustainable development based on information available, that number could be as high as almost 68%, based on doing more than even the policies have currently sort of suggested be done. So there's still room for improvement, even if we got to that 50% mark. So this is a talk about engineering and renewables. So that was a prime on renewable side of things. So now I'm going to talk about the career options in engineering and how they really tie to renewables as well. One of the things people often mistakenly think is that when you think about renewable energy, you're really only thinking about electrical engineers, maybe mechanical engineers, and pretty much that's it. I think well, that's it. You know, they're all making energy and making electricity, and so that's what I'd have to do if I want to get into the renewable career arena. And that is not really the case. Renewable energy, as you saw from some of the examples I talked about before, comes from a variety of sources, and it's also affecting our lives in more and more ways, and in ways that we didn't necessarily envision it before. I mean, right now, many products have solar cells on the product itself, solar lights, solar security cameras. All these sort of things are now integrating solar into the products that are more mainstream from the average consumer's perspective. And so that means more and more engineering disciplines are getting involved in the renewable field as well. Additionally, people are now tying renewables to our environment and the benefits renewables have for our environment. And so that branch of engineering is also getting involved. If you think about it, just about every branch of engineering has a role to play in renewables. And so I'm trying to get people to understand that if you want to be a chemical engineer, or you want to be, chemistry is your thing, but you want to work in the renewables field, so you're not into electrical engineering or mechanical, you want to do chemistry, and you think that means you are excluded from being involved, you are not. Solar panels, fuel cells, these technologies revolve around a chemical process. The developments and the improvements in solar panels and fuel cells are going to come from improvements in materials, chemical processes. I'm developing different reaction technologies in order to get those products to be more and more efficient and also be smaller and smaller so they can be more and more practical and at the same time cost less for the customer. So in looking at disciplines, you know, there are tons of disciplines, and there are going to be lots of job opportunities developing in these technological areas coming out of renewable development as a result. And so people often think engineering is mechanical, electrical, chemical, civil, and that's pretty much it. But really, each of those have multiple subdisciplines underneath that, and these subdisciplines also have branches under them. So engineering is one of the broadest fields that you can think of to get into if that's a career choice. And often when you go to engineering school, even though if you start off in a mechanical program or an electrical program, a school will often try to expose you to as many of the other disciplines as possible. So that in that first year of your academic career, you can decide whether you want to shift your majors or go down a different branch or start thinking about what specialty in the field that you're in that you might be interested in terms of your final papers, future master's and PhD programs, and any sort of research you may want to get into. Because that's what it's all about. Engineering on a day-to-day basis is pretty much the application of known processes and known technologies to achieve a solution or to develop a project. But on the long term, engineering is about taking new technologies and new techniques that researchers have developed and making those into new products and new solutions for problems that we have on the planet. So, you know, think about it. What has changed in the last 5 years? All of these things on this list, and this is a very abbreviated list, are things that did not exist 25 years ago. So all of these had engineering input into their development. Now, these may not be renewable specific, and that's because a lot of the renewable technological developments have happened in the background, but you don't really see it at the consumer level per se as a new product. But original solar panels used to be, you know, like 5% efficient. They're up to around 23% efficient now. The push is to try try to get them to 75, 80% efficient, because that means less panels on your roof for the same amount of power. It means you could possibly get panels now on a car that produce enough solar energy to charge the car without having to plug it into a separate power source. So the development in the industry is still constantly going on. And so all of these things, when I was growing up, were pretty much science fiction. No one thought you would be able to walk around and have access to data on a device in your hand with a screen and a camera, and it could play music and could give you directions to get to a rest. Just didn't think about it. That was Dick Tracy sort of stuff. You thought it was gonna happen, but you didn't really know what it was gonna look like. But these things are now all commonplace because of engineering. And so even in the engineering field on the renewable side, there are a lot of jobs in the industry. This was a 2018 survey, and it shows that there are about 11 million jobs worldwide in the renewable space. And so solar is one of the big ones, because solar is getting more and more pervasive, and it's a sort of a mature technology. Bioenergy has a big chunk as well. Hydro has always been there, and wind power, has gotten a big kick over the last decade or so. But some of those other technologies we talked about, ocean thermal, fuel cells, those are things that are coming down the pipe. Toyota recently announced that in Japan, they haven't brought it to the North American market yet, but they have their first fuel cell powered car. The auto industry is going to be one of those industries that is going to drive renewable technology in some way, because as we saw, we had, believe it or not, we used to have battery operated cars right at the very beginning of Henry Ford's era, but batteries weren't very good then. So combustion engines took over. But now people are realizing combustion engines aren't that good. That's all the fuel crisis issues and dependency on oil. So now battery technology is being developed significantly, to the point that more and more electric cars, practically every major automotive maker has committed to having electric cars as the main part of their fleet in the next 10 years. And so that direction is changing. But there are those who say batteries only can get us so far. So if you're even thinking about engineering now, and you're thinking about that direction, you want to think about the technologies that are yet to come as well, and seeing where your interest is in those. Because those are going to be the iPads and the iPhones and stuff as you are stepping and getting into your career in a big way. So, these are many things that are being worked on that in the next 25 years will probably be mainstream. Autonomous self-drive vehicles, they can sort of drive themselves a little bit now, but with car manufacturers, you still have to be there to take control, but the technology is improving. So we're going to get to the point where instead of going to Avis to rent a car, and you get in the car and you have to drive everywhere, you get in the car and you just tell the car where you want to go, and the car carries you there. Air taxis, Lyft have indicated that they intend to develop an air taxi. I think there's a functional air taxi service in Dubai. Of course, that's Dubai. You can afford anything in Dubai, but it shows the technology is coming to the market. And once one person does it successfully or nearly successfully, others are going to replicate that and improve upon it. And so these are going to be the technologies of the future. There is going to be a time when there probably will not be an electricity grid the way we know it now. It will be likely that you will generate your power at your home, and that power will be fed into a network that is decentralized, such that if you have excess, it may go to your neighbor who needs more, and vice versa. This means a whole paradigm shift for utility companies who have had a historical way of producing electricity all this time, centralized stations with large grids to try and get the power to the customer, whereas that whole mechanism may get flipped on its head. And engineers are going to have to be in that process to figure out how does it work? How do you convert the old grids? How do you get from where we are to that new paradigm as smoothly and as easily and as effectively as possible? We talked about hydrogen fuel cells. So they are coming. Artificial intelligence. So if you want to be an engineer in the computing space, artificial intelligence is going to play a major part in things like that grid revolution that I just spoke of, in developing technologies that make renewables more efficient through control systems, monitoring systems, manufacturing systems. All of these things are driven primarily by software. And the goal is to get the software to be more and more intelligent in the decision-making process. So you would help there. And on we go. And ocean-based, consumer robotics, digital implants and human augmentation, and carbon-neutral towns and cities and countries. They are all things that are coming. And so the show talk about how transportation is going to be driving this is right now, you can see the amount of electric cars that are being put on the road right now is driving a change in the auto industry, and that's going to drive a change ultimately in the renewables industry because they use a lot of the same technology. So as you can see, there's a lot of opportunities in engineering. And there's people who will advise you to invest in solar. So I always have this one slide that I put on in my presentations for the young and the young at heart who may be in the session. The best solar investments you could possibly make. It can be easily financed. The installation is relatively simple. It has minimal moving parts. It has very low maintenance costs. It's fully automatic. It's a tried and true technology and can be used all over the world. What is it? It's a solar-powered clothes dryer. And I'm pretty sure everyone's seen one, but they never thought about it that way. That's what it is. Doing things like switching how we do things is often one of the best investments we can make. Out of convenience and moving with the modern times, many of us have moved away from the simple clothesline to dryers running on electricity and gas. And that has happened somewhat to the detriment of the globe as a whole, because it means more energy production, more carbon into the environment, simply because we wanted more convenience. But it's sometimes we, as a people of the planet, as a citizen of the planet, we have to start looking at the fact that we have to look out for the long-term health of the planet and not just our short-term preferences. Granted, something else may come along, and BPL is currently investing in things like solar in order to diversify our energy mix. We partner with the Ministry of Environment and the government on other projects in order to get those projects going. So it doesn't say that renewables aren't a way to go when I do my whole clothesline spiel. But what I'm trying to say is that using energy as efficiently and effectively and using alternative methods when you can that are just as effective is something you should always do. Conservation is the cheapest form of energy and has the biggest cost payback that you can find. So whenever we could do that, we should try and do so. So at that point, I end my presentation and I open the floor to any questions that anyone may have. No question? great question there. What do I think is the most difficult thing to do in engineering? I don't think a lot of it depends on your personal skill set and what you find easy and what you don't. You know, I could never be a bioengineer because in biology, I could never remember the names of everything. It was just, I just could not act. That was not my thing. I have difficulty with remembering people's names, so I guess it's based on the same thing. But someone who is very good at that will say that's not hard at all. In the electrical engineering area, and in math areas, those sort of areas, chemical to a certain degree, the mathematics is what often frightens people away from the engineering field. So for some of the hard engineering disciplines, not hard as in hard to do, but what is considered the more traditional, electrical and mechanical, civil, that can be a challenge. What are the best colleges for engineering? The best colleges are going to be your MITs and your Caltechs and places like that. Of course, those are high-end schools with very high tuitions, etc. I think it's more about getting into a good program. So you have to do some research on the college to find out if it has a good engineering program or engineering background, and many of the colleges in the US do. And then trying to apply yourself in your field where you can. Engineering is greatly dependent on applying yourself in a job or in a field, getting the experience and building on that experience. Coming straight out of college, even if you went to an MIT or something, you may be brilliant, and that may be good for research. But if you're coming into a practical environment, to a power company or a construction firm or civil engineering firm, what counts a lot for is how you take that academic knowledge and apply it in the real world and develop the experience. So I wouldn't lean too much on the college, but of course, if you want to get a good engineering background, you make sure to find schools that have a good ranking in the engineering field. And there's just too many for them for me to even begin to say. Are there many women in the Bahamas working in the engineering area? There probably are not enough. Historically, females have either been dissuaded or not found technical fields as attractive. That is not anything to do with ability, that it was just a social sort of correct thing that existed. There aren't as many as there could be, but there are quite a few. In some of my areas back in BPL, we have quite a few females in the technical areas. We have female environmental engineers, female planning engineers, or planning technicians, planning assistants. So, we have, quite a few in BPL, but I'm saying that, do not necessarily limit your horizon to the Bahamas. Yes, we want people to go out, get skills, and come back and help build our society. But at the same time, if a broad base of experience is what you want to get, if opportunities present themselves for you to do that in other countries, take those opportunities and get that experience and then bring that back. Because our country is still small, we're still developing in many ways. And so the exposure that you get here is going to be limited. So you do want to take advantage of opportunities that might present yourself to get more exposure elsewhere before you come back. Any other questions? Nope, either that means I did a great job, I did a terrible job. One of the two. One of these days, somebody will tell me. I leave it to the junior achievement moderator to let me know if there's anything else, or if that's it for us for today.
Yeah,